All right. So welcome to this session. I think previous sessions have covered a couple of open source security projects or standard practices which are used in open source security. So this talk is more about how we as an open source project have adopted different security practices, how we have implemented those in practice. And probably you can refer most of these in our source code, which is open on GitHub. So this talk is mostly about Fission OSS project. So Fission is open source software. Brief about me. So I'm a principal engineer at InfraCloud. I've been maintaining Fission for past couple of years. Apart from that, my interest areas are cloud, containers, and distributed systems. In past, I've worked as a Linux kernel engineer. So mostly I worked on distributed system protocols within kernel, etc. And then I have also contributed to OpenStack. I have maintained few projects in OpenStack, and also I've been Go developer mostly past couple of years. I love to tinker around open source in general. I've been maintaining a couple of my own projects as well as I've been contributing to different open source projects. So a bit about Fission. So Fission is a Kubernetes native function as a service platform. That means you can run Fission anywhere on any cloud or on-prem. It's a cloud-native platform with Kubernetes as a base, and most of our users use Kubernetes either within different clouds or on-prem as well. We have a wide community adoption. We have 8,000 plus stars. We have a couple of enterprise users who take Fission, customize it as per their needs, and provide their own services on top of Fission, mostly like paid services or cloud, their own software as a service solutions. We have around 2,000 plus monthly installs, and then we have also a couple of broad deployments where we have 200 plus nodes being used for Fission functions, deployment, and delivery. We are fast and flexible, so we support a couple of flexible strategies to deploy and deliver function calls. So we have strategies like pool manager, etc. So you can definitely check out all those things if you're looking for a performant and fast serverless solution on top of Kubernetes. We also support different programming languages. We provide the runtimes for different programming languages like Java, Python, Go, etc. So there are different ways you can invoke functions which are deployed on Fission, like HTTP trigger, MQ trigger, type trigger. So I'll briefly cover those. And of course, we also have support for observability tracing if you're using, let's say, OpenTelemetry, etc. So we support wide variety of standards in general. So this is a bit of a Fission landscape. So we have Fission in core, and then you write functions in different languages. So we provide runtimes for different languages like Java, Node.js, etc. So you write function, you deploy it on Fission. Fission can also build the function you have written. Once the function is built and deployed, you can invoke functions in different ways. Like there are HTTP URLs, cron functions, MQ trigger, which is message queue triggers. So that means we support different message queues like Kafka, SQS, etc. So you can integrate integrate Fission with your existing message queue system as well. And then of course we have support for different observability and different platforms like this. So this is a bit quick overview. Like we write a function, hello world, hello.js function. So this is just like we take a request, we process it, and then we return a response, right? So this is a simpler function. Once you write a function, we just deploy it with Fission CLI, and you create a route to call that function, and you can you can instantly invoke that function, and you get the response. So this is high level, right? Now, when we talk about security, so I just wanted to showcase a strategy by NIST, which is for Secure Software Development Framework. So this is a 4 key point strategy. One is like preparing the organization. That means you have people on the team who understand security and who can essentially develop secure software, right? And then you develop a software such that you are reducing the target surface or you reduce the attack surface on the software that you are writing, and you are introducing less and less vulnerabilities in your software. So ensure that you are producing well secured software. Then you also need to ensure you are responding to the vulnerabilities as quickly as possible, so that if you come to know about any vulnerabilities, you are patching your source code quickly, delivering a latest release, etc. So so at Fission we consider these standards in general. So I think couple earlier speakers have already covered OpenSSF scorecard, SLSA guidelines, CII best practices, etc. So OpenSSF scorecard is a sort of a low touch project, but it gives you a lot of value. It evaluates couple of security if you are following all the security practices or not. Let's say a simple checks like if you are merging codes without reviews, or let's say you're not passing enough checks when you're merging the code, etc. So OpenSSF can capture those, and probably it will reduce your score. So your score, OpenSSF scorecard score sort of gives how you are following all the secure practices, etc. So you can see our badge on Fission, and then you can check what all practices we follow, etc. SLSA guidelines. So I think we had in previous session we covered Sayam covered I think all the practices and all the levels, etc. So we try to follow that, and then there is CII best projects. So this is more sort of making your open source project more community friendly, as well as it tries to ensure that you are following all the qualities, etc. Quality standards, etc. in your project. And so this is CII best practices are more like you self-certify yourself that I'm following as an open source project, I'm following all these practices, etc. And then of course there are certain practices which are given by different GitHub open source guides, so we try to follow those as well. Now, so I think we have briefly covered this, but so SLSA identifies different threats which can occur at different layers of your software, either at source level, build level, package level, dependencies, etc. Right? So you need to ensure you are not getting any unauthorized changes. There are no compromised, there's no compromised source code as such, or you're not getting any vulnerable dependencies in your project. Then whatever build steps you have in your project, you need to ensure that those build steps sort of maintain the integrity of all the software packages that you are delivering, and you're not at any point of time you're not delivering compromised packages. So a brief overview of what all things we have in terms of Fission. So what all probably threat actors, a threat map sort of. So we have in terms of sources, we have like Docker files or Docker files, Helm templates. So we also deliver Helm charts to our users. And then we have GitHub workflows, which are mostly driving a lot of things around Fission. In terms of dependencies, we have different build tools. We use like Go Releaser, Golang, CLint, etc. We also use a couple of external GitHub actions, container-based images, etc. So these are more in terms of dependencies. So if you are an open source project, you can probably map what all things you are using and then try to reduce attack surface on those areas. And in terms of artifacts, what we deliver is we have around 8 to 9 container images that we deliver to our users. Then we have Fission CLI, which our users use to interact with Fission. There are different Helm charts, which are sort of packaging layer, which helps Helm charts essentially help you to sort of deploy your microservices on Kubernetes. And we also provide different environment runtimes, which are used to run different functions on the Fission platform, right? So now we have understood all the sources that we have in Fission. Let's understand how we review what is the process of getting a change in Fission. So this is briefly sort of a map that I have built, and maybe if it makes sense, you can follow similar strategy in your open source project as well. So once we get a PR from or trusted or signed or So either there will be a new contributor or let's say already known contributor, etc. So there are a couple of checks that we generally run. So there are lint and unit tests. So of course every project would have. Then we also measure code coverage, how much code coverage we are getting from all the tests. So if we are like reducing the code coverage, definitely we try to push contributor to increase that. Then we have CI test, upgrade test. So these are like sort of essential checks that we need to ensure. So upgrade test that like we need to ensure that if user is going to upgrade, we should not break it from the previous versions. Now, when we talk about security, so we run CodeQL scans on our source code. So we so what if there are any vulnerabilities, CodeQL will raise an alert on the PR, and then we have to fix that PR, and then only we can merge the PR, right? So in terms of dependencies, if that PR has any new dependencies getting introduced, or if we know there are vulnerabilities in existing PRs, etc., existing dependencies, we try to fix those. And then of course there are secret checks. We are not introducing any secrets in terms of the PR, etc. So once all these things are done, we try to reviewers will review and it goes into our main branch, and then of course there are scorecard scans which continuously run on the main merge, and we try to ensure. So with this, we try to ensure we are getting right changes in Fission in terms of security. So as an open source project, so mostly there are different tools that give you sort of handle on all the dependencies that you have. We try to scan all the dependencies sort of on the weekly basis, and as well as through each PR that we are not introducing any vulnerabilities. As well as we try to pin the dependencies, whatever versions we are getting in. So I'll try to showcase how we pin those dependencies. As well as we sort of runs CI runs, as I mentioned previously. And so we use Dependabot, which is sort of provided by GitHub. So that is quite helpful in terms of all the dependencies scan, etc. So mostly we have dependencies, Go modules, GitHub Actions, container-based images. So we try to ensure all these dependencies, we are not getting any vulnerable issues, etc. Now, just to give an example, like let's say if you are using GitHub Action, you are using external dependency, right? So earlier, let's say we are just mentioning that use actions checkout at v1, something like that. So, but the problem with this is like this particular dependency can change. So you need to ensure you are pinning right commit hash along with dependency. And whenever there is a change, Dependabot will raise a PR to your project that, okay, this dependency is vulnerable and probably need to change that particular dependency. So if you are maintaining an open source project, try to ensure you are pinning all the dependencies. And of course, OpenSSF scorecard scans all these things, and then it will report to you that, okay, you should fix these things, etc. Similarly, like if you have Docker file, so earlier we used to use Alpine image, but it has probably a larger attack surface. A lot of binaries are shipped with it. So we switched from it to a minimal image from ChainGuard that is static. And then we also, so this was, and after that we saw like a lot of reduced vulnerability reports. And even further to that, now we have added a checksum for the base image. So like whenever you're getting any base image in your Docker file, try to pin all the dependencies that you have. Similarly, so this is more for Go source code, but let's say if you are developing application in any other projects, try to ensure you're pinning all the versions that you're using, as well as you have some sort of way to cross-verify those dependencies are not changing, and if they're changing, you get alerts. So so Go does a very good job at this. It will capture all the checksums of all the packages that you're using. So yeah, I mean, definitely ensure these practices. So this also helps us to build the SBOMs around the binaries that we are building. Because of all the dependencies are pinned, once you build the binary from, let's say, Go source code or any other language, you get all the SBOMs being maintained in the same binary. So this is a bit about the release workflow that we have. So once we are ready for a release, we create a Git tag in GitHub. So we use Go Releaser for creating releases mostly. So first step would be like probably we generate all the binaries. So in terms of like whichever are going to be used for our project. So there's Fission, CLI, etc. And then there are also container images. So even for container images, we build first all the binaries, and mostly these are cross-platform. That means we have to support different OS as well as different architectures. So we build out all those binaries. Then we embed all these binaries in container images wherever they are, or the base images which I mentioned just earlier. Then we sign all these images with cosign. Once all these images are signed, etc., we also generate SLSA provenance, which was covered in earlier talk as well. So once all these provenance, etc., is generated, also we since we ship Helm manifest as well, so we have to sort of generate artifacts for Helm as well, and then publish those to Helm repo. So all these things are done and verified. Then we just generate the changelog and publish release artifacts. So all these process basically what gives our users like it gives us our users confident that okay, they can download a cosign signature or like a signature for that particular binary, and they can verify okay, this particular binary was built in right way, as well as from the provenance they can verify this particular package or this particular container image and binary is being built in a in a right manner, and they can also see all the source code that we have in GitHub, how this particular things are being built. So just a sample like how we do this. So we use Go Releaser. So this is a GitHub action. You can also refer all the source code on in our repo. So we just run Go Releaser with a couple of keys and all. So we also use cosign, etc. And once Go Releaser finishes, it generates checksums for all these binaries, etc. Then we also generate provenance for those particular binaries as well as container images. And user can verify these particular binaries or container images once they download or once they get these things with SLSA verifier. So that's sort of pretty much covers what what practices we follow to ensure secure software delivery in Fission. Of course, we continuously try to improve the practices that we have, and it's very tough job being an open source maintainer. So you have to cover a lot of ground to get these things done in the project. So right now, so we are targeting couple of additional things getting done in next couple of next releases. So we are trying to get CIR best practices gold batch, as well as probably we'll try targeting L3 level completion, as well as right now we have only we have provenance only for binaries, but we are also trying to get provenance for images, and of course improve our score on OpenSSF scorecard. Follow practices such as fuzzing, enablement, etc. Okay, that's pretty much what I had in my session. Yeah.